Hello everyone. In this session we are going to see about sequencer output. Let's see where is the instruction. So you can see file shift bar sequencer. Okay. So whenever you want to have a control of the sequence operation, you can make use of this instruction. So in the file shift and sequencer menu, you can see SQO, sequencer output. So just click on the instruction. So this instruction is having various parameters. First is the file number, then it is a mask, then it is a destination, the output file, then there is a control part, then length, then position. Okay. So what are the inputs over here is file, mask, control, length. Okay. So these four are the input parameters and destination and position are output. Okay. So destination is the complete 16-bit file. So where you are going to see the output. Mostly it will be the output file like O:0/0, that one. Okay. And the file number and mask should be the binary. So I have a program for that. I'll open that. Yeah, can you see the file over there? Hold on. Yeah. So in this sequencer output, I have given the file number as B3:0. That hash automatically it will take. Okay, B3:0. And the mask bit I have given as B3:10. Fine. And the destination file O:0.0. Complete file I have taken. See, I have not given as a bit. Okay, I have given as complete 16-bit file. One channel I have given. Okay. And this is the control file. Okay, R6:0. You can get from here. Can you see? Control. So this is taking care of the controlling part. Fine. And this is the length. You need to give this a integer. You can give from 1 to how many numbers according to the processor the limit will be. So I'm giving here as 4. And the position is automatically changing whenever you are going for online. So what it will actually do, I'll tell you. So in the example or in the exercise session, you will be seeing example like four-way traffic light control or two-way traffic light control, like that you will be seeing, okay, in the exercise or in example problems. So there we are in need of to write multiple rungs. Fine. So take a four-way traffic control. So there you are having 12 outputs. Okay. So each direction 3 outputs. So 12 outputs. For all the 12 outputs, you will be connecting in the rung. Fine. So all the 12 outputs should have some necessary, needed conditions. So to reduce the number of the rungs, you can make use of this sequential block. Okay. So how to turn on multiple outputs with a single condition? Okay, so it will reduce the number of rungs if you are using this block in the four-way traffic light control, right? So what exactly it will do means, for each and every position, so for example here I have given length, length is 4 here, right? So for this, each and every rung, whenever this switch is going on, the position number will be changing. Okay, so according to the position numbering, it will be feeding the output file with some 1s or 0. It will update the files for each trigger. Okay, so I think I can go for online so that you can understand better. Hold on, it's loading. Yeah, fine, I'll go for online. So I have given the file name. Okay, apart from that I have not given anything else. Now I am going to give, just take a binary file. Okay, so in the binary file, mask bit we have given as what we have given, B3:10. Can you see? Mask bit. And we have already discussed regarding the mask, right? Like the comparison block and all we have seen. What we have seen, mask bit need to be 1. Fine. So for example, B3:10 I have used means all the bits need to be 1 so that it will exactly give the output. Whatever input you are giving, that will be comparing with the mask bit. Okay, mask bit, if it is 0, it will not process. So mask bit should always be 1. Fine. So what I'm going to do means, I'm going to take this mask bit completely to 1. So instead of typing 1, I need to update here. Okay, 1 1 1, like I need to update here because this is a input file. You need to give the input. So I'm going for this hex and I'm just giving here as F F F F. Okay, now you go for, oh, I didn't press the enter. Okay, now go for binary. So everything is 1 1 1. Fine. So this is the first step we need to do. This is, in our example, I'm just giving everything as 1. According to the requirement, you can change the bit. For example, you can go for first 4 number as 1. Okay, so that's your wish. And the second point here is just to open this output file and keep it here. Okay. Yes. Now, what is the file number we have given over there? B3:0. Fine. B3:0 I have given. So what is the length I have given? 4. So how it will take the input file means, it will take B3:0 we have taken, no? So it will take B3:1, B3:2, B3:3, B3:4. Since I have given the 4 length, it is taking length 1 as this one, length 2 as this one, length 3 as this one, length 4 as this one. Got it? So now update your file. For example, when the length is 1, see, when you are triggering this, it will change to position 1. Okay, in that position 1, it will read this file. Okay, it will read this file. According to that, it will turn on your output file. For example, see here, I am turning on this one. Okay, this is my input file. Okay, next, for second position, whenever this fellow is going for the second time, I'm turning on this output. Okay, next, whenever it is going on for the third time, I'm giving this one. Okay, and give the fourth one is here. Let's see what is happening. Fine. Got it? So I have updated the input file B3:1, B3:2, B3:3, B3:4. For example, here you have given the position as, length as 6. You need to update these 2 files also. Fine. I'll go for the first trigger. Let's see. Turning on. Can you see what is happening here? This O:0.0 will be updating. Don't bother about these 3. Okay, everything will be updated in the O:0.0 because I have given output there. See, destination file is O:0.0. So it is updated here now. For the first, see, position is 1 now. So it is reading B3:1. What is position number 2? B3:2. What is the file? This one, first bit. So it will be turning on now. Let's see. Now if you turn off, it will remain in the on condition only. It will not off and all. Okay. Now, yes. Can you see? It is changed. Got it? Yeah. Can we do the third trigger? What is happening? Third file. Because B3:3. Correct? Now, fourth trigger. Can you see? It is updated, no? Fine. Now turn off. Now what will happen? See, position is equal to length now. Fine. Next, that's it. 1 cycle is completed. Now if you press for the 5th time, it will go back to the first position. Can you see? It is updated here. Okay. So it's not only for the 1 bit. You can give multiple bit also. I'll show you. Now you update this. You can update wherever you want. See, you are updating like this. Just update whatever, according to the requirement you can update. Fine. That's it. Now this is 1. So it is showing this. See, just now I have updated. Fine. So let's go for the second trigger. Can you see the second trigger? 1 1 1. Can you see here? This bit, this complete rung. It is updated. See, 15th bit is also 1. Correct? So let's go for the third trigger. Yeah, fine. It's updated. Now fourth trigger. That's it. Okay. I hope you have understand the working of this sequence. Fine. For example, if I am turning off all these mask bit except the last 4 bit. Let's see that. I'll show you. Instead of F, I'm just giving 0, 0, 0, only one F. Okay. Now go for binary. Now this is only happening, right? Now if you go for the first trigger, it will be working. Can you see it is updated? Okay. But can you see this is also turning on? Fine. This is also turning on. But in my output file, it was not there. Okay. This is why still in on condition means in the previous position. What was the previous position? Length 4. Correct. In the length 4, these two fellows were on. That's what these two are on. For the next cycle, since mask bit is off, it couldn't able to filter it out. See, mask bit is off here. No, that's what it couldn't able to update the 0. So it is continue with its previous position. Okay. So better you keep all your mask bit as 1. Okay. Else it will not update. Fine. So see, even though if I go for the second trigger, it will be still there. Okay. All the 4 bits are updated continuously. See, for the second bit, you are having 15th bit as 1, but it is not updated here. Correct? Because mask bit is 0. Got it? Fine. So this is how you need to use the sequencer output. So all the corresponding outputs, see O:0/0, these and all you can use it in your program if you want. But the basic concept is you need to give the binary inputs and mask bit. According to that, it will be updating here. Got it? So just practice this in the software. I'll meet you in the next session with another interesting topic. Fine? Yeah. Bye.